Now we're going to look at what are called composite functions, and that's when you can combine two functions together. Probably the best way to explain it once again is I like the concept of mapping when I talk about functions. So if we have all these x values here and h of x maps my x value to a new value. So here h of x is 3x plus 1. If I put x equals 2 as input, 2, 3, 6 plus 1, 7. So I'll end up at the point 7. And then g of x takes that point and maps it to a new point. And my question is there a way we can work out one single function rather than do it in two steps? Is there one single function that will take that point and end up at that point? And that will work for any point I want to try and choose in for x. So even though I'm shown it here only for one point, can I come up with one function that will take any point here to what will happen if I do it in two individual steps here? And that's what a composite function is. Now we write composite function, so this is the composite function g of h of x. Now this is what normally gets done first, what's in here, and this is what gets takes place second. So here we used h of x first, and then we used g. We acted with the g function next to do the second mapping. So the way to work it out is g of h of x. We look at the one on the outside and we go and have a look at that function. And the pattern is 4 minus 2 times something squared. So I'll write that, but instead of writing the x, I'll just put some brackets. So 4 minus 2 something squared. Now that has given me the pattern. The g function is 4 minus 2 times something squared. This something is the h of x. This is what this means. This is why I've got the brackets here, those brackets there. So inside here is the h function, which is 3x plus 1. So it goes in the brackets. If this was 4x minus 2x squared, I'd go 4 bracket minus 2 bracket squared, and then in the bracket I'd put 3x plus 1. Now if it was 4x, I'd put 4, so on. Okay, so then I've got to remove the brackets. Now one thing is got to be really careful of here is I've got a negative outside some brackets, which means all the signs inside are going to change, and that 2 is applied to everything inside. So I get 4 minus, I'll leave the 2. The 2 is not squared, it's only what's in the brackets that's squared. Using FOIL or whatever you like, you can actually do the expansion of this, and you should get 9x squared. The way I do it is you square the first, square the last, plus 1 squared is plus 1, and then it's twice the product. 1 times 3x is 3x, times 2 is plus 6x, and that is the expansion. So when you've got a plus b all squared, it's a squared 2ab plus b squared. So you've got first term squared, last term squared, twice the product of the two. Now I can apply the times negative 2. Now that negative 2 has got to be multiplied everything inside. So I'll get negative 18x squared, and then negative 12x, and then negative 2. Like terms, well, I've got no, only got one term containing x squared, one term containing x. I've got two constant terms here. 4 minus 2 is positive 2. As I've said before, it's usually good to write these what I call polynomials in ascending or descending, and if you can start with a positive, that's good. So let's just start with the 2. 4 minus 2 is 2, and then we'll go up. So that's minus 12x minus 18x squared. So that's g of h of x. So if you like, rather than do a point, map it with the h function, then map it again with the g function, you can put a value in there and it'll take you all the way from there up to there. What would be h of g of x? Okay. Look at the h. The h is 3 times something plus 1. 3 brackets plus 1. That's my h1 with the brackets there. Now inside the brackets I'm going to put g of x. G of x is 4 minus 2x squared. Remove the brackets and I get 12 minus 6x squared plus 1. And 12 plus 1 is 13 minus 6x squared. You can see that they are not the same. So in general, g of h of x is not equal to h of g of x. Another way to write that, g of h of x, is just g, a small circle of h. That's another syntax, if you like, for composite functions. This would be log h composite g. Okay, and in this case, g composite h is not equal to h composite g. Occasionally you can get functions, but in the majority of cases you can't assume that those two are going to be the same. So there's composite functions, some basic steps to be able to calculate and simplify the function, and as long as you can understand the concepts up there, that should be all okay.